Assalamualaikum and hi everyone, and a very good day to all my dear students. I'm Cikgu Rozi Norazia binti Mat Rizwan from SMK Tanah Merah 1, Kelantan. Today, we are going to do discussion on structure question Fizik STPM 960/3 based on G Cakna Kelantan module on section B, question number 16 and question number 17. I hope at the end of discussion, students are able to answer the question confidently and improve your answering skill. So, let us identify the best way to cope and master the question. We should focus what the question need from us. Okay, here you can see the answering techniques. Step 1, clarify the key points. Step 2, identify the chapter and subtopic. Step 3, visualize what is occurring and diagram it. Step 4, list down the given quantities with units and related formula. Step 5, identify the unknown values and what question need. And last but not least, step 6, perform unit analysis and calculate the value with proper units. Okay, section B is a compulsory section where all students need to answer the question in this section. Question 16 and 17 will give 15 marks in total. Okay, so let's start with question number 16A. Next. Question number 16A. A form of progressive wave which has a frequency of 800 Hz and a speed of 350 meter per second can be stated in the form of the following equation. Y equal to A sine in bracket omega t minus kx, where x and y are in meter and t is in second. What is the distance between the two positions which give the phase difference of pi radians? Okay, using step 1, identify the key points. As students can see, I have highlighted the important points. And next. The key point is progressive wave, which is from chapter 20, wave motion. Progressive wave is a wave whose wave profile moves in the direction of wave propagation. Progressive waves are divided into two, which is transverse progressive wave and longitudinal progressive wave. As you can see, the figure shows plane progressive wave. There are 4 equations can be used in this topic, which are y equal to A sine omega t minus kx, y equal to A sine in bracket omega t minus 2 pi over lambda x, y equal to A sine 2 pi in bracket t over period minus x over lambda, and y equal to A sine 2 pi over lambda in bracket vt minus x. Okay. From the question, students are required to list all the information first. The related formula from progressive wave equation are identified. Okay, we know that frequency equal to 800 Hz, velocity is 350 meter per second, and then we know that velocity equal to f lambda. Then we come up with lambda equal to v over f. So substitute the value into the equation, then it gives us the value of lambda is 0.438 meter. This part will give you 1 mark. After that, compare the equation from the question with general equation. As you can see, the equation of k is 2 pi over lambda. From that, we substitute the value of lambda into the equation and we get the value of k is 14.3 meter per 14.3 per meter. We settle with 16a, then we continue with question number 16b. Question number 16b1. Figure A above show the water wave from a source at O. The displacement of the particle at the surface of the water at a distance x from O at a certain instant is shown in figure. 1. What is the wavelength of the wave? From the figure, the wavelength of the wave can be determined by the displacement distance graph. As you can see, one complete cycle of the wave, lambda, recorded as 4 cm. Let's continue with question number 16b2. Explain why the amplitude of the wave decreases when x increases. For this question, students should understand that the intensity can be related to the amplitude and radius of area. From the figure, we can justify that the intensity of a wave is the energy per second transferred by the wave to a unit surface area perpendicular to the direction of wave propagation. Then, the formula for intensity given as power over perpendicular area, and the unit for intensity is watt per meter square. From the formula, we can relate the intensity with radius of area as intensity is inversely proportional to r square. Also, intensity is directly proportional to the square of the amplitude of the wave. Since intensity is directly proportional to a square and inversely proportional to r square, then amplitude is inversely proportional to r. So, as the wave front increases with distance r, the amplitude of the wave decreases. So, the answer should be written as the wave front increases with distance, so the energy is spread over a larger area as the wave travels. Hence, the intensity of the wave decreases with distance. As intensity proportional to amplitude square, amplitude decreases with distance. Let us continue with question number 16c. Calculate the ratio of wave intensity at Q to the wave intensity at P. From the equation of the intensity, intensity is directly proportional to the amplitude square. We can see from graph the intensity of P is 16 and the intensity of Q is 2. Then, substitute the value into the equation. We get IQ over IP equal to AQ square over AP square, and it will give us the answer of 0.016. Dear student, let us continue with question number 17. 17a. State the Huygens principle. Huygens principle topic are from chapter 23 wave optic and under the subtopic 23.1 Huygens principle. Huygens principle, also known as Huygens construction. Huygens assumed that light travel in the form of wave. According to Huygens, a point light source emits spherical wave. The surface of each sphere is known as wavefront. A wavefront is the locus of point vibrating in phase. The figure below shows how the secondary sources form a new wavefront from secondary wavelet. So, from the Huygens theory, we can summarize that the Huygens principle states that every point on a wavefront acts as secondary point source. The surface tangent to the secondary wavelet form the new wavefront. We continue with question number 17b. Sketch the wavelet for Huygens principle. As student can see, 2 marks was allocated for this question. For every question that asking student to sketch, there are 2 important things must be included in the answer. First, a complete diagram. Second, the label for each part in the diagram. Figure shows that every single point of secondary wave source creates the new wavelet, which is known as the secondary wavelet. And as you can see, there are 2 marks given in this section. Next. We continue with question number 17c. Apply the concept of Huygens principle to explain interference phenomenon and state the formula for the fringe separation in Young's interference pattern. Draw a label diagram to support your answer. As student can see, I have highlighted the key points for this question. Every single point will give 1 mark, and for this question, 4 marks was allocated. Okay. From the figure, we can see how Huygens principle explain about double slit interference pattern. S1 and S2 are 2 coherent sources of light producing spherical wavefront. By using Huygens principle, new wavefront can be constructed propagating in different directions, forming the central maximum, the first order and second order maximum in the interference pattern as shown in the diagram. And for this sentence, it will give you 2 marks. Young two-slit interference pattern is used in the experimental determination of the wavelength of monochromatic light. From the experiment, it gives us the formula of fringe separation as x equal to lambda d over a. So, for the total mark given in this question is 4 marks. Dear student, that's all from me. I hope all students can improve your study and answering skill in STPM Fizik Semester 3. Thank you.